So in this lesson we are going to look at inequalities, and just to get us kind of started in inequalities, we're going to look at the different sets of numbers that you will come across, particularly when you're working with inequalities. So if we think about the first set, so the first set are what are called natural numbers. So natural numbers are what are known as the counting numbers. So if we take, for example, the numbers, so 1, 2, 3, 4, okay, and so on, all the way right up to infinity. So these are positive whole numbers, and they're what are known as the natural numbers, and they're represented by the letter n. So in mathematical questions, you'll see them refer to natural numbers using the abbreviation of n. Now, sometimes you might be asked to plot natural numbers, for example, on a number line. So if we take something like this, so this is our number line. We start in the middle at 0, so to the right, when we move to the right, we are moving in the plus direction. Okay, so that's moving in this direction here. And then if we're moving to the left, we're moving in the negative direction, or the minus direction, which is this direction here. So if you were to look at the set of natural numbers donated by the letter n, we would be looking at, so if we wanted to plot them on a number line, so 0 isn't a natural number, so we're starting at 1. Okay, so 1, 2, 3. Okay, so it will go in this direction, and it continue on in this direction right up to infinity. So these are the natural numbers. They're called natural numbers or counting numbers because they are used to count things in nature. For example, if you look at the objects that are in the room or around you or in nature, if you're to count the number of trees, for example, that's in your garden, if you're to count the number of chairs that's in the room that you're in, you will use natural numbers to count those. And a way you can think about it also as well, if you think about it from a set point of view, so imagine we have the set which is natural numbers, so it's something like this. So, and that's going to be all the positive whole numbers will be contained within this set. So the next one then are integers. So again, integers are represented by this letter Z. Okay, so it's used to represent integers. And integers are all of the positive and negative whole numbers. So basically, it would include the set of all natural numbers, and then it has the additional, for example, the negative and positive whole numbers. Okay, so it goes in both directions. So for example, we'd have, so let's say minus 1, 0, 1, 2, 3, etc. So these are all, and you'd have minus 2 then. So these are all what are known as integers. So you'd have negative 1, negative 2, negative 3, etc. Okay, so these are the integers, and a way to kind of think about it is if you have a set of integers, that would include the set of natural numbers, and then also have the extra negative numbers as well. So if you were to plot this on a graph, for example, you would have, so for example, you'd have all of the negative and positive numbers going in this direction, and then you'd also have all of the negative numbers going in this direction then as well. Okay, so that's the integers, and again it's used as symbol Z is used to represent it. Real numbers then are all, basically you can say every number is a real number. So this is like a huge set that contains the integers, it contains the natural numbers, and then it contains all the other numbers as well. And they use the letter or to represent real numbers. So for example, you have like numbers that are not whole numbers. So for example, 1.62, okay, or 3.45. So numbers like this, also pi, for example, would be included in that as well. And then if you wanted to represent, for example, natural numbers on the number line, you would basically be coloring in the whole number line. So it's going to contain everything that's on the number line. So for example, it'll include the numbers between each of the whole numbers. So for example, the decimal numbers, and include all of the whole numbers as well. So these are the three kind of sets, if you like, of numbers that you will come across when you are dealing with integers and when you're dealing with other mathematical problems as well. But inequalities then are basically, so inequalities basically contain they contain these symbols here. So we have these different symbols here that we talk about. So we have an equal sign. Okay, so this is, we're familiar with this when we're using like linear algebra, but inequalities are these guys here. Okay, so basically when we have an equal sign, we know that one side of the equal sign is equal to the other. But when we have inequalities like this, it means that one side of the equal sign is not equal to each other. So let's have a look at these signs, these what are called inequality signs. So the first one would be, so for example, this means not equal to. So if we had something like this, so for example, 4 is not equal to 2. So the equal sign, we're very familiar with that. So you could have something like this. So 5 is equal to 5. Now these are the inequality signs. So a way to think about it is, you can think about the sign, it's kind of like a mouth, and the mouth eats the biggest number. So sometime in primary school they might refer to it as a crocodile, and the crocodile eats the biggest number. So basically the mouth eats the biggest number. So this means greater than, this means less than, this means greater than or equal to, or less than or equal to. The other way to think about it as well is that the less than sign represents, it looks like an L, a lopsided L, which represents less than. So examples of this, for example, would be if we had something like this. So 6 is greater than 3. So this is what's called an inequality. We can say that 3 is less than 6. That's the way that you'd read it. We can say that, so this is greater than or equal to. So if we were to say something like this, so x is greater than or equal to 6. Okay, so what would that look like on a number line? So what we're saying is that the value for x is it could be a number anywhere between 6. So for example, 6, 7, 8, 9, and then that would go on indefinitely in this direction. So it could go all the way up to infinity. So basically, and this is 6. So this inequality, so x, for example, the value of x would fall somewhere in the range of, so it could be 6, or it could be any of the numbers above 6. So it could be any of these numbers here. So x is greater than or equal to 6. The next one then, you could have something like this. So x is less than or equal to 6. So you could have something like this. So it would be the opposite. So it's less than. So let's say 5, 4, 3, 2, and then this will go on indefinitely in this direction to infinity. So again, this here, so this top one is x is greater than or equal to 6. And then this bottom one would be, so x is less than or equal to 6. So it could be any value from 6, for example, all the way right down, including the negative numbers. So it would be anywhere from 6, 5, 4, 3, 2, 1, and then it could go on indefinitely in that direction. So that's what we mean by, that's what, like when we talk about the inequality signs, that's what we're talking about. So we've been looking at equations, for example, so equations are basically like algebra expressions that have an equal sign between both sides of the equation. So instead of having an equal signs between both sides of the equation, we have one of these inequality signs. So we treat them almost like equations, but there are some differences. So let's have a look at some examples of inequalities. So here are 3 examples of inequalities. And what we're going to do is we're going to work on each of them, and we're going to solve for the value of x. So let's work through each of these inequalities. So there's one rule. So basically what we do is we treat them exactly like equations, linear equations that we've looked at already, except with one rule. So we have this rule. So if we divide or multiply by a negative number, we have to reverse the inequality sign. So otherwise we treat the inequality sign as an equal sign. So why is that the case? So let's have a look at something like this. So we can say that 3 is less than 4. Now, when we are working with equations, what we do is we can manipulate either side of the equal sign. So, for example, we can add or subtract or multiply or divide either side. Now, with inequalities, so if I, let's say, minus 1 from both sides, that's going to be, so 2 is still less than 3. Okay, so if we subtract a number from either side of the inequality sign, it doesn't have an impact on the sign. If I add a number to either side, so plus 1 and I plus 1, this will become 3 is still less than 4. Okay, so we're back to this. Now the problem is if I multiply or divide both sides, again that's okay. So I multiply by 3 and multiply by 3. If I multiply by a positive number, that's going to give me 9. So 9, for example, is still, so 9 is still less than 12. Okay, so we can multiply either side by a positive number. If I divide either side, so let's say if I have the inequality, so 9 is less than 12. So if I divide both sides by 3, let's say positive 3, this will become, so 3 into this goes 3 times, is still less than 3 into this will go 4 times. So again, the inequality still holds true if I divide by a positive number. Now the only difference is that if I take an inequality, so let's say 3 divided by 4, and if I divide both sides by a negative number, so let's say I divide this by negative 1, so I divide it by negative 1, and I divide this by negative 1. Okay, so now I'm dividing both sides by negative 1. So what will happen then is that this inequality, so 3 divided by negative 1 gives me negative 3. And then 4 divided by negative 1 gives me negative 4. Now the problem with that is that negative 3 is actually smaller. So negative 3 is actually bigger than negative 4. So if we look at a number line, for example, negative 3 will come before negative 4. And likewise then as well, if we do the same, so let's say if we have a number line like up here, so let's say we have negative 4 over here, so we have negative 4. So we can see that on the number line, so negative 3, which is here, is greater than negative 4, which is here. So when we divide either side of an inequality by a negative whole number or a negative number, we have to flip the sign of the inequality. And then the same thing applies when we multiply either sides of an inequality by a negative whole number. We have to flip the signs. Okay, so it's just important to kind of bear this in mind as we work through these questions. So let me just rub this out. And what we'll do is we look at some examples of this, but just this is the rule here that it's very important that you need to remember. So let's look at some examples of this in action. So again, I'll just put the rule, I've just put it up here just so you can see it. And let me just pull this down a little bit. So let's go through the first question. So this is an example of an inequality. Why is it an inequality? Because it has this inequality sign here. So what we want to do is we're trying to solve for x. So solve for x. And we treat it exactly like an equation except for this rule here if we have to divide or multiply either sides by a negative number. So let's look at this first one. So what we want to do is we want to get x on its own. So again, we have to add 3 on both sides to get rid of the 3 here. Or no, sorry, not add 3, but we have to subtract 3, should I say. So minus 3 and minus 3. So plus 3 minus 3, that's going to cancel out, and that will leave you with 2x is less than or equal to 11. And then what we can do then is we can divide both sides by, sorry, that's not 11, just change this here. So 11 minus 3, that's going to leave me with 8. And then what I can do is so this is 2 multiplied by x, so I have to divide this side by 2, divide this side by 2, and that's going to leave me with x is less than or equal to 4. And again, if I want to draw this on a number line, sometimes they ask you to draw it on a number line. So we have, let's say, so 4, 3, 2, 1, and that'll go all the way to infinity. So it goes in this direction. So again, if we wanted to write that on the number line, so x is less than or equal to 4, so it starts here and includes all of these numbers all the way right down to infinity. So instead of x just having one value, x in the case of inequalities has a range of values. So that's the first one. So the next one then, let's have a look at this. So again, what we want to do is we want to solve for x. So again, I have to just change the color here. So I have to minus 3 from both sides to get rid of the 3. That's going to leave us with minus 2x. Plus 3 minus 3 cancels out, is less than or equal to 8. So again, now what I have to do is I have to divide both sides by negative 2. Divide this by negative 2. So this will become x, and this here will become minus 4. Remember, like signs give plus, unlike signs give minus when it comes to working with when we're dividing or multiplying integers by each other. So if the signs are the same, like they are in this case, it turns the answer positive. If the signs are different, like in this case, this is positive, this is negative, the answer will be a negative indice. So again, x is, so now this becomes negative 4. So what we have to do is we have to flip this inequality sign. So it becomes something like this. So x is greater than or equal to negative 4. So again, if I wanted to write this on the number line, so this is question 1, question 2. So it's saying that x is greater than or equal to negative 4. So we'd start at negative 4, negative 3, negative 2, negative 1. Okay, and then the number line will continue on in this direction all the way up through the positive numbers. And what we can say then is that, so we would include, so x is greater than or equal to negative 4, so it would include negative 4, negative 3, negative 2, negative 1, and it would move in that direction and include all those numbers. And then we can see there as well how we have used this rule because we've had to divide both sides by a negative number. And then the last one then, so sometimes you might get an inequality that has a fraction in it, so you need to be able to get rid of the fraction. So in order to get rid of this fraction, what I have to do is I have to I can multiply the fraction by, for example, the lowest common multiple, which is which in this case it would be 2. Okay, so what I can do is I can multiply each of these by the common number, the lowest common multiple. So let's change this here. So I can multiply both sides by negative 2. So I multiply this by negative 2, multiply this by negative 2. So what will happen is this negative 2 and this negative 2 will cancel out. Okay, so this will just become x minus 2. And then I have to flip the sign because I've multiplied both sides by a negative number. So this will become less than negative 7. And then what I can do is I can divide both sides by, I'm going to have to add 2 here and add 2 here. So these will cancel out and it'll leave me with x is less than, so minus 7 plus 2 is equal to minus 5. And that's just, if we have a fraction, we can just multiply by the lowest common multiple. So that is inequalities, and that's what they are, and that's what they're about. And then this is working or solving inequalities, and then this is the important rule that comes into play when we're working with inequalities. Okay, thank you for listening.